What's going on, guys? Welcome back. Hope you are doing well. I'm super excited to bring you today's video, which is about async streams in Swift concurrency. So we're going to do a brief overview, and then we're going to dive straight into the code to do some examples. So let's go ahead and just talk about what these are. So this is a powerful addition to Swift's concurrency model, introduced in Swift 5.5. It allows us to create asynchronous sequences, which can be particularly useful when dealing with streams of values that arrive over time. So some examples of this, guys, include real-time chat apps, where we're constantly getting incoming data in form of a real-time chat. Stock and crypto apps, where we're constantly receiving price updates from an API. And really anything that streams or pushes data to our device. So if we have a constant stream of incoming data, async streams are going to help us accomplish this within the Swift concurrency model. Before, we had to use things like snapshot listeners, if you're familiar with Firebase, WebSockets, and things like that. And we pretty much were stuck to or bound to completion handlers. But now we have a way to transition all of that into the Swift concurrency model. And that's what we're going to be doing an example of here next up. So let's go ahead and dive into Xcode, guys. And before we hop into the code, guys, I wanted to show you our Messenger Pro Plus app that fully utilizes async streams. So this will give you guys an example, or a real world example rather, of how async streams can be used in production ready applications. You guys can see here that this chat app is completely seamless. The real-time chat functionality is incredible. And like I said, that is fully utilizing the async stream stuff that we're about to get into here. And that is available on the website at stephencodes.com/courses. And you guys will see that here, and the link is in the description. So if you guys want to continue learning after this video, make sure you go ahead and check that out. Let's go ahead and get started with the code now, guys. So I have Xcode opened up here, guys, and you should just get a Swift UI view opened up. We're going to be starting from scratch with this whole thing to really break down this async stream concept here. So really quickly, let's just go ahead and build out some basic UI. We're going to build out an example that mimics getting data from a cryptocurrency API. So we're not actually going to be connecting to one. We're just going to be mimicking that functionality. So let's imagine we're looking at the price for Bitcoin, right? And we are going to just have BTC and then text, and we're going to say like $0, right? So we can just go ahead and give this some padding. And this is our UI, okay? So basically, guys, let's imagine that we want to mimic receiving real-time price updates on Bitcoin in this application. So how are we going to do that? So let's go ahead and actually create something called a data provider. So I'm going to create a class called async stream data provider. And this is going to be where we get our data. So I'm just going to go ahead and say func. I want to get my data with this class. And I'm going to have a completion for an @escaping double. And that's going to be a void completion handler. So then, guys, I'm just going to create a quick little price array. You guys can go ahead and do the same. Just come up with a little prices array of the data that we're going to be mimicking here. You could also make this a class level property. It doesn't have to be inside the function. We're just going to loop through this guy and execute our completion handler for each one of these values to mimic those coming in over time. So here's how we're going to accomplish that. We're going to say for I in 0 up to, but not including prices.count. Oops. Let's say let price equal prices I. Then we're going to say dispatch queue, and this is to mimic a delay, guys, .main.async after. And we are going to use this option that says deadline with the execute option, and make sure you use the execute option that executes a completion handler. So we are going to say deadline is .now plus double I, and we are going to execute our completion with our price. So essentially, guys, I is going to start off, let's see, we need to make this an array of doubles, or we could just do integers here. It's all good. So basically, guys, I is going to start at 0. So we're going to get the first value back immediately. Then I goes to 1. So that's going to give us a 1 second delay. That's what this does. Then it's going to give us the next price. Then I will be 2, and the price will be 68,521. And the delay will be 2 seconds, and it will give us back the 68,521 price, so on and so forth. So this is just a quick little way of mimicking like a delay of incoming prices, okay? So now how do I actually get this data, right? So this is what I'm doing things the old way first, and then going to show you guys how async stream comes in to save the day and allows us to operate within that Swift concurrency model. So next up, guys, let's create a class for our view model, async stream view model. This is going to be the typical observable object. And this, guys, is going to have a published property for our current price, which is just going to be an int, and we can default it to 0. And then we're just going to call this function here. So I'm going to say func get data with completion handler. Sorry, my Xcode is being a little laggy. Get data with completion handler. And I'm going to create an instance of my data provider. So I'm going to say like private let data provider equal my async stream data provider. And then here I'm going to just say data provider dot get data. And you guys will see here now that I have access to this completion handler, it's going to give me back that price. And I'm going to say self.current price equals that price that comes back from my completion handler. Pretty straightforward stuff if you guys have ever worked with completion handlers before. And also, if you guys have done that, you're going to know that we are going to want to utilize a weak self here to avoid memory leaks and retain cycles, and make that self optional because we are accessing a property that exists outside of that closure. So now we're set up to go ahead and implement our view model, guys, and get this data showing up inside of our view. So that should be pretty straightforward. We're just going to say @state object var view model equals my async stream view model. And then, guys, I'm going to just go ahead and say that I want to make this guy my price. So I can go ahead and just do an injection here and say view model.current price, right? So now the only thing I need to do is launch that function or trigger that function, right? So in my view model, I could just go ahead and say init, and I could say get data with completion handler, right? So you guys will see now that it's going to go ahead and cycle through those prices, right? So that's pretty cool. So we get a 1 second delay between each price, and this is really mimicking like what a crypto or stock app would look like with getting data back in sort of real time and having that information just constantly getting pushed to our device. But you'll see here, guys, that we're obviously working with completion handlers, and completion handlers suck, right? The whole purpose of the async await model was to eliminate the usage of completion handlers because they can get really messy and they have a ton of drawbacks. So fortunately, this is where async stream comes in to save the day. So it's going to allow us to get data in the same way with that sort of stream of data, but it's going to allow us to operate within that Swift concurrency framework. So guys, let's go ahead and add another function here. We're going to call this get async stream. And this is going to return an async stream, and it's going to ask us for a data type. And we are just going to be streaming integer values, right? So this is what the syntax of this is going to look like. Instead of having a completion handler like we do here, we are now going to be returning this async stream. So here's what we're going to do, guys. We say we want to return an async stream, and we are going to open up some parentheses. And you guys will see here, we have a bunch of options with our input parameters. We really just need to build this stream. So just go ahead and hit enter, and then hit enter again. And that is going to give us access to this closure, which is going to give a, and we're going to be using this continuation within this closure. And we're going to be using this continuation to control the flow of the data to our view model. So we're going to see how this works in just a second. So we're still going to use this function here. So there are instances, guys, in which you can't really escape using completion handlers, right? So an example of that would be with something like Firestore snapshot listeners. They haven't really converted that to async streams yet. So there are instances in which you're going to have to use completion handlers. Async streams give us a way to sort of shift things over to Swift concurrency by acting as a middleman, so to speak. So let's go ahead here and say self.getData with this completion, and we're going to get access to our price, right? So we're still utilizing this completion handler, but now it's all within the data provider. And what we're going to do is say continuation.yield. and we're going to yield that price. So this is just a way, as I said before, of controlling our data flow, right? So as we get data back from our completion handler, which like I said, can mimic something like a WebSocket or a snapshot listener, we are going to use our async stream continuation to yield that value. Okay, so that's all we have to do there, right? Now let's go back to our view model and actually see how we can implement this inside of there and how we are actually going to transition into our Swift concurrency model now. So I'm going to go here, guys, and I'm going to just say func get data, and it's going to be an asynchronous function. And we are going to say for await price in data provider dot get async stream. And then we're just going to say self.current price equals that price. So this is now the new tech, okay? This is all we got to do to now utilize this async stream and update our current price value. We no longer need to operate with completion handlers and utilizing weak self or anything like that, because we are now getting our data with an async stream. And guys, what that means is we no longer have to call this on the init on our view model. We can actually go ahead and attach a task to our body, and I can now say await view model dot get data. And you guys are going to notice that this functions exactly the same way. So that's incredible, guys. So we see that we are able to transition from utilizing a completion handler to an async stream so that the thing that consumes that data provider, this view model, can now work completely within a asynchronous context, right? Or utilize that Swift concurrency model, which is so cool. So basically, guys, we're going to run a for loop, and it's just going to wait for each one of those price values to come back from our async stream, and then it's going to update our price data. And guys, you certainly don't have to use completion handlers here at all. But like I said before, there are situations in which you can't get away from that. And this gives you a way of converting that stuff that uses completion handlers into an async stream. But you could have very easily written this code in such a way where you don't need this function. I just wanted to show you guys how to use async stream as a middleman to go from completion handlers back into Swift concurrency. So really quickly, let's see if we can do that. If you guys want to know how this would work full stop with async streams. So instead of saying self.getData with that completion handler, we could do pretty much the same here. We could just say for I in 0 up to prices.count. And then we can literally just go ahead and grab all this code here, paste it in, and replace completion price with continuation.yield price. And you guys will notice this functions exactly the same way, right? So you guys could do this completely using async stream if you have an API that supports async streams, but if your API only supports utilizing completion handlers, that's how you can also convert that into using async streams, guys. So next up, let's just go ahead and do a quick overview of what all of this is, just to make sure we have a really solid and concrete understanding, and then we'll dive into some slightly more advanced concepts with async streams that are very important to understand if you're going to use this in an app, guys. So basically, we are now returning an async stream instead of utilizing completion handlers. And then inside of our view model, we are able to await the values that come back from that async stream. As we can see here, we're waiting for each price to come back, and then we are updating our value right here, and we are publishing that over to our view so that it updates accordingly. And we see that we no longer have to use these ugly completion handlers, guys. So we do so with use of this continuation. This continuation is a mechanism that allows us to control the flow of values and the life cycle of the async stream. You can use it to yield values, finish the stream, or throw an error. That's right, guys. We also have async throwing streams, and we can get access to an error type here as well. We're not really going to be working with this much. Just know that if something goes wrong, you guys can also yield errors from your continuation. So this supports throwing capability as well. And something else you'll notice, guys, is the continuation can yield failures or successes. So it also supports that result data type that we get natively from Swift. We can yield some sort of failure, or we can yield some sort of success in addition to the value that we are specifying that we are going to be yielding. And this is fully generic, guys, meaning that we can yield any sort of data type that we want. Structs, classes, integers, strings, whatever it may be. So now that we've done that quick little overview, let's go ahead and go over some continue learning with async streams. And these concepts are very important, guys. we are going to start with how to terminate a continuation. So what's important to understand about this is as follows. Guys, anytime you have an await keyword in your code, it creates what's known as a suspension point in that code. So I want us to go ahead and add some print statements to this getData function so we can see exactly what's going on here. So I'm going to go ahead here and say print started stream, print streamed price, and we'll look at the price. And then afterwards, I want us to say print ended stream. Right? Let's go ahead and run this app, guys. I have set the root view of my application to be my async stream module, and we can see here that we're getting these print statements back. We are getting this warning that we're publishing changes from background threads. We'll fix that right now, and let's go ahead and run that again. So let's make our view model here a main actor class and run this again so those errors go away. And let's go ahead and take a look at our print statement. So we started the stream. Streamed 1, 2, 3, 4, 5 prices. But here's the super interesting part, guys. We never got the print statement that indicated that our stream has finished. So our code never gets to this point on line 58 here because we technically never ended that stream, and we still have this suspension point in our code. So it's literally stuck here, right? Which isn't necessarily a bad thing if you want to keep that connection open to whatever your data provider or your API is. But there are times in which you're going to want to terminate that stream, right? So how do we do that? Well, we go back up here, and after we complete this for loop, let's imagine that we don't need any more prices from our API, or we want to trigger some event that terminates that stream. What we are going to do, guys, is say continuation dot finish. So let's go ahead and run this again, and that's going to terminate that stream, and then it's going to allow our code to continue execution. Huh. It just ended the stream. That's weird. So let's go ahead and, okay, so I think what happened was this didn't execute the way we wanted it to. Let's go ahead here, guys, and inside of this dispatch queue.main.async after, we are going to say if I equals prices.count -1, then we are going to say continuation.finish. And let's go ahead and run that again. We need to say self. So the reason that didn't work, guys, is because we were inside of a closure here, because we're trying to mimic this sort of like delay. And you guys will see now that it ended our stream. So once I executed this continuation, that .finish method, it's going to go down here and it's going to allow my code to continue on past this suspension point, right? So that's a super important point on how you can terminate your continuations. Another very important point, guys, is you might want to do some sort of teardown after your continuation finishes. So let's go ahead and go up here to the top. And this behaves much like the defer functionality does in Swift. And I have a video on that on the channel as well if you guys want to look up that. You can say continuation.onTermination. And we actually have to set this equal to this closure. And you guys are just going to open up some brackets. You can say _in, and you could just say print handle teardown or dinit, right? So let's go ahead and run this and see what happens here, guys, with our print statements. And once again, this just allows you to execute some sort of code once the continuation finishes, right? So we can see here that we need to handle our teardown. Looks like that happened a little earlier, a little out of order, but that's fine. The concept is, or the purpose of this concept is to show you guys that you can execute some sort of code once your continuation finishes here. So this gets called, and then this block gets called. And basically something I use that for in my code, guys, is when I have something like a snapshot listener and that connection terminates, or a WebSocket and that connection terminates, you want to make sure that you remove all of those listeners or close that WebSocket on your back end. And that's what you can do in this onTermination method. So that's pretty much going to wrap it up for our async streams, guys. As you can see, this is a super powerful tool. And if you guys want more on how to actually use this within a real mobile application, highly recommend checking out the Messenger Pro or Messenger Pro Plus app, guys. This is a fully functioning, real-time, production-ready chat app. Let me just go ahead and show you guys how awesome this is. Just like go ahead and add some message, and you guys can see here that things show up instantly. And this is fully utilizing async streams, guys. So this is a real-world project in which you can see how async streams are used. And the Pro Plus course which is available right here at stephencodes.com. In our courses section, the link is in the description. This goes through a full breakdown of how to convert code that uses completion handlers to code that uses async streams when working with things like snapshot listeners using Firebase for real-time updates. So make sure you guys go ahead and check that out. You can also become a member with us on the website for less than a coffee a day, guys, to get full and complete access to all of our courses. Pro Plus is actually not included with the membership. I do want to make that clear. There's way too much value in here for me to just include that for 40 bucks a month, guys. But you do get access to all of these pro app clones: Messenger Pro, Tinder, Airbnb, Instagram, all of that stuff. All of these fundamentals courses as well, and all of our app templates, obviously with the exclusion of Pro Plus. So make sure you guys go ahead and check the website out at stephencodes.com if you want to continue learning. Also, guys, I'm going to be doing a full Swift concurrency masterclass. This is just one module that's a part of that. As you can see here in the completed code, I have a bunch of other stuff that's going to be coming to the website and the channel. So get excited for that, guys. Make sure you mash that like button, subscribe to the channel to see more content like this. And thanks for watching, guys. We'll see you in the next one. Peace out.